Hello viewers, I am Deepti. On special request of some of my viewers, I am going to cover unit trigonometry, from which first part is trigonometrical identities, which is today's topic for class 10. The whole chapter revolves around three identities, which are sin square theta plus cos square theta is equal to 1. We can make it as 1 minus cos square theta is equal to sin square theta also. And then next is 1 plus tan square theta is equal to sec square theta. We can also convert secant square theta minus 1 is equal to tan square theta, but you need to learn these plus values. Then next is 1 plus cot square theta is equal to cosec square theta. These three identities are the base of this chapter. You need to learn these. Then next is what is cot theta. Cot theta is cos theta upon sin theta. And what is tan theta in terms of sin and cos? It is sin theta upon cos theta. What is sec theta? Sec theta is reciprocal of cos. It means 1 upon cos theta. And what is cosec theta? It is 1 upon sin theta. After learning these things, you may start the chapter now. Why these are my favorite questions? Because these are the only questions which have answer in front of you. And it is very easy for you to prove RHS and LHS are equal. Now, starting with the easy one, we may have more than one method to solve the question. So, first question is cosec A plus 1 upon cosec A minus 1 is equal to 1 plus sin A, 1 minus sin A. Now, if I am going to start with LHS, then just need LHS and start. Now, cosec is 1 upon sin A plus 1, and then again 1 upon sin A minus 1. Taking LCM of the numerator, it is 1 plus sin A. LCM of the denominator is again sin A, 1 minus sin A, then 1 plus sin A upon sin A, multiply sin A upon 1 minus sin A. Sin A is cancelled, 1 plus sin A upon 1 minus sin A. Therefore, RHS is equal to LHS, and hence proved. So this is the shortcut method of doing this question. Now I am going to solve this same question with another method. LHS remains same, cosec. Now suppose I want to solve this question by rationalizing the denominator or by multiplying or dividing the numerator and denominator with the same number, and because minus sign is here also, so I want to multiply and divide with cosec A minus 1 and cosec A minus 1. So in the numerator A plus B, A minus B, it means A square minus B square. In the denominator, this is cosec A minus 1 whole square. Numerator cosec square A minus 1 is equal to cot square A. This is third identity. Denominator, we can open it or we can again put 1 upon sin A instead of cosec A minus 1 square. Now cot square A in the numerator, and in the denominator 1 minus sin A, and in the LCM sin A and then square. Now cot square is cos square upon sin square, and here this sin square A goes to the numerator and 1 minus sin A whole square. Now sin square cancel, cos square A upon 1 minus sin A whole square. Now we know that cos square is equal to 1 minus sin square A upon 1 minus sin A whole square. Now 1 minus sin square A is 1 minus sin A and 1 plus sin A square minus B square. In the denominator, 1 minus sin A is 2 times because square is there. So we can cancel 1 and then 1 plus sin A and 1 minus sin A is our RHS. In this way we can also prove, but you can see this is the long method. So we will opt short method, but this will come with the practice. One more easy question, 1 upon tan A plus cot A. We will start with LHS, 1 upon. Now we know the value of tan A in the term of sin A and cos A, it is sin A upon cos A. And what is cot A? It is cos A upon sin A. Then 1 upon, in the denominator LCM is sin A into cos A. Then multiplying sin square A plus cos square A. It means 1 upon, we know the identity sin square of cos square is 1. So 1 upon sin A into cos A. It means sin A into cos A is our numerator now, and this is our RHS also, because multiplication is commutative. So it is cos A into sin A. Now coming to third question, which is cosec 4A minus cosec square A is equal to cot 4A plus cot square A. In LHS we can see that cosec square A we can take common. So cosec square A is common, and inside the bracket cosec square A and minus 1. Now cosec square A minus 1 is equal to cot square A. So cosec square A into cot square A. If we want to simplify, we can further simplify it by writing sin square A, and cot square we can write as cos square A upon sin square A. It means cos square A upon sin 4A is our LHS. In this case, we can solve right hand and also for the simplicity of the question. So taking right hand side, we can take cot square A common from both these terms, and then cot square A plus 1 inside the bracket. Then cot square A plus 1 again equal to cosec square A. Now simplifying it, otherwise we can left it this step also. The step is same, we can leave this question like this also. Now cot square A, it means cos square A upon sin square A, and then cosec is 1 upon sin square A. It means cos square A upon sin 4A, which is our LHS. So at the end, LHS and RHS are equal, so hence proved. Next question number 4 is 1 minus cos A, 1 plus cos A under the root is equal to sin A, 1 plus cos A. Now in this type of question where there is the difference of plus and minus only in the numerator and denominator, we can multiply the denominator and numerator with the same number, or we can rationalize it. Two methods are there, but here denominator is same. So we just need to solve LHS. It means under root 1 minus cos A, 1 plus cos A, and we need to multiply both numerator and denominator by 1 plus cos A and 1 plus cos A. So in the numerator, 1 minus cos A, 1 plus cos A, it means A minus B, A plus B. It means A square minus B square. And denominator, 1 plus cos A, 1 plus cos A, it means 1 plus cos A square under the root. Now 1 minus cos square A is equal to sin square A, and 1 plus cos A whole square under the root. Now under root and square both will cancel, then sin A upon 1 plus cos A is our right hand side. So LHS is equal to RHS. Our next question is sin A plus cosec A whole square plus cos A plus sec A whole square is equal to 7 plus tan square A plus cot square A. We will start with LHS. Sin A plus cosec A whole square, A plus B whole square. It means A square plus B square plus 2AB. A is sin A and B is cosec A. We can reduce one step by writing 1 upon sin A instead of cosec A. Then in second bracket cos A plus sec A whole square. So cos square A plus sec square A plus 2 cos A into, again we can write here 1 upon cos A instead of sec A. Now sin square A plus cos square A. We need to put them in one bracket so that we can put identity here, sin square A plus cos square A. Instead of cosec square A, we need to write 1 plus cot square A, third identity. Then sine cancel, 2 from here. Then sec square, we can put here sec square 1 plus tan square. And then cos cancel, 2 is here. Now sine square plus cos square is 1. 1 from here, 2 from here, and then 2 from here. And then this one also. Then tan square plus cot square. Now adding all these numbers, we will get 7. Then 7 plus tan square A plus cot square A. And answer is in front of you. This is our right hand side. Hence proved. Our next question is sin theta multiplied by tan theta. In the denominator there is 1 minus cos theta. And in RHS 1 plus sec theta. Again started with LHS, sin theta. And tan theta we can write sin theta upon cos theta. In the denominator 1 minus cos theta is here. And here sin multiplied by sin square theta upon cos theta, denominator 1 minus cos theta. Sin square theta we can write 1 minus cos square theta. And cos theta in the denominator and 1 minus cos theta in the denominator. 1 minus cos square theta we can write 1 minus cos theta, 1 plus cos theta. A minus B, A plus B. Then cos theta, 1 minus cos theta. Now 1 minus cos theta cancel, then 1 plus cos theta and cos theta. Now we can separate them, 1 upon cos theta and then cos theta upon cos theta. It means 1 upon cos is sec theta and cos upon cos is 1. Sec theta plus 1. This is our right hand side and hence proved. Our next question is sec a upon sec a plus 1 plus sec a upon sec a minus 1 is equal to 2 cos x square a. Now coming to LHS again. In the denominator sec a plus 1 and then sec a minus 1. Here multiplying sec a minus 1 and then sec a, this side sec a plus 1. Sec square a minus sec a and then here sec square a plus sec a. In the denominator a plus b, a minus b, it means a square minus b square. It means sec square a minus 1. Now sec a minus sec a plus cancelled. So it is 2 sec square a. In the denominator sec a square minus 1 is equal to tan square a. Now 2 sec means 1 upon cos square a and tan means sin square a upon cos square a. So cos square a cancel, 2 upon sin square a. And what is 1 upon sin? It is cos x. So cos x square a. 2 cos x square a is our right hand side and this is the correct answer. This is our next question. Cot a plus cosec a minus 1, cot a minus cosec a plus 1 is equal to 1 plus cos a sin a. Starting with LHS, but here we need to apply one trick. Otherwise this question will be very lengthy. Cot a plus cosec a as it is, and instead of this 1 we need to apply the identity of 1 from third identity, cosec square a minus cot square a. So instead of 1 we are writing cosec square a minus cot square a. In the denominator we need not to change anything. So as it is cot a minus cosec a plus 1, we need to apply the third identity instead of this 1 here. Now cot a plus cosec a minus, this is a square minus b square. So a minus b and a plus b. Denominator no change as it is. Now cot a plus cosec a is present in both of these terms. So we can take it out common. Cot a plus cosec a is common. From the first bracket only 1 will inside the bracket, minus from second bracket, because we have two brackets cot cot A plus cosec A is common, and inside the bracket cosec A minus cot A is present, and denominator there is no change. Now cot A plus cosec A, then 1 minus cosec A minus minus plus cot A. In the denominator, cot A plus 1 minus cosec square A. So we can write it as 1 minus cosec A and plus cot A. It means same bracket in the numerator and denominator. We can cut them. Now cot A plus cosec A. What is the value of cot A? It is cos A upon sin A. And what is cosec? It is 1 upon sin A. In the right hand side, sin A is the LCM, and then in the numerator cos A plus 1, or you can write 1 plus cos A upon sin A, and this is our right hand side. So here only one trick, instead of 1 we need to put the identity in the numerator, but we need not to change anything in the denominator. So this is the easiest method to solve this question. This is a very important question from examination point of view also. In next question, 1 plus sin A upon cosec A minus cot A minus 1 minus sin A upon cosec A plus cot A. This is our LHS. So starting with it, we can take LCM here. So cosec A minus cot A, and then from second term cosec A plus cot A. We need to multiply these two. 1 plus sin A cosec A plus cot A, then minus 1 minus sin A, and then these two, cosec A minus cot A. Now multiplying 1 with these two terms, we get cosec A plus cot A. But when cosec A is multiplied with sin A, this sin A and then cosec is 1 upon sin A. So, and then next term, sin A multiplied with cot is cos upon sin A. Minus, in second bracket, with 1 we will get the same term cosec A minus cot A, and then minus sin upon cos, cosec A, it means 1 upon sin A again, and then minus minus plus sin, and then cot is cos A upon sin A, bracket close. In the denominator, this is A minus B, A plus B, it means A square minus B square, and we have recently put this identity, it is equal to 1. So in the denominator we will left with only 1. Now in the numerator, cosec A plus cot A. Sin cancel, it means plus 1. Here sin cancel, it means cos A. Then minus, we are opening this bracket, minus cosec A plus cot A, minus minus plus 1, and then minus cos A. In the denominator we will have only 1, so we can leave it. Now this cosec A plus 1, this is minus cosec A, and cot and 1, and this 1. Cos again cancel. So 1 plus 1 is 2, and 2 times cot means 2 cot A. So we can get 2 common and 1 plus cot A. This is our right hand side. So hence proved. One more question. 1 upon sin A plus cos A plus 1 upon sin A minus cos A is equal to 2 sin A upon 1 minus 2 cos square A. Again starting with left hand side, here we have sin A plus cos A and sin A minus cos A. So we can take LCM here also, sin A plus cos A, then sin A minus cos A. So multiplying with 1 we will get sin A minus cos A, and here we will get sin A plus cos A. So cos and cos is cancelled. So 2 sin A. In the denominator we will get A plus B, A minus B. So A square minus B square. Sin square minus cos square. But here we are getting cos square, so we need to change this term sin square according to first identity. So we know that sin square A is equal to 1 minus cos square A, and then this cos square A. So 2 sin A upon 1 minus, now this will get 2 cos square A. So 2 sin A upon 1 minus 2 cos square A. This is our right hand side and hence proved. Normally we will get one angle with the trigonometrical identities in either A or theta or B, but here I am solving this question. This is a very simple question with A and B, two different angles. So go with simple rules, taking left hand side. Tan A is sin A upon cos A, so tan square is sin square A and cos square A, minus tan square B is sin square B upon cos square B. Now taking LCM, cos square A into cos square B, multiplying sin square A with cos square B minus sin square B with cos square A. Now sin square A and sin square B is in the right hand side also, so we can change cos square B. Now sin square A, and instead of cos square B we can write 1 minus sin square B, and here sin square B, and then cos square A we can write 1 minus sin square A upon cos square A into cos square B. Now opening sin square A minus sin square A into sin square B, again in second bracket sin square B minus minus plus sin square A, and then sin square B, in the denominator cos square A and cos square B. Now sin square A, sin square B in plus and in minus, so we can cancel both of them. So sin square A and minus sin square B, in the denominator cos square A and cos square B is equal to right hand side, hence proved. Take care that in the right hand side sin square and sin square B is there, so we not to put identity instead of these two. So we left sin square A as it is and sin square B as it is, and put identity at the place of cos square B and cos square A. 1 minus sin square B and 1 minus sin square A, these terms will get cancelled and we will get ultimately sin square A minus sin square B in the numerator. Now coming to last question, 1 plus cot A minus cosec A, 1 plus tan A plus sec A, two separate brackets. So we will take left hand side, then 1 plus cot A. Now we know that cot A is equal to cos A upon sin A, and cosec A is 1 upon sin A. And here 1 plus tan A is sin A upon cos A, and then sec is 1 upon cos A. Now taking LCM, this is sin A, so here we need to multiply with it 1 sin A, it means sin A, plus cos A, then minus 1. Here taking LCM, this is cos A multiply 1 cos A, then sin A, then plus 1. Now sin A plus cos A minus 1, and then you can see these as separate brackets. A minus B, A plus B. So A square minus B square. A, this is our whole A square minus B square. 1 square we can left. So in the denominator we will have sin A multiplied by cos A. Now A plus B whole square. A square plus B square plus 2 AB, then minus 1 upon sin A cos A. Now sin square A plus cos square A is equal to 1 plus this 2 sin A cos A, and then minus 1 upon denominator as it is. So 1 minus 1 is cancelled, 2 is intact, sin A and cos A is again cancelled in the numerator and denominator. So answer is 2, which is our right hand side. With this, I conclude my today's video. If you have any doubt, you can tell me in the comment section. In next part, we will do questions from height and distance. Thank you for watching till the end. Keep watching, sharing and subscribe to my channel, and don't forget to give your comment in the comment section. Thank you.